All right, so these are our 3 notes. We have 2 sections today. We're going to do notes and a little bit of an activity. And then if we have time, we want to get you some time to get you started on your worksheet that will be due on Thursday. So to refresh our memory, we talked about plotting points last class. What else did we talk about? Creating charts, right? So then you could graph. So you would put in some X values, see what you get for your Y values, and then you plot those coordinates. And then hopefully you were always getting a line. So what this brings us to is now you're going to be giving these X's and these Y's. And another term for those is your X's, and this will come, we'll talk more about this, not necessarily in this class, but more probably in 65. X's are also known as your input, and we could also call Y your output. The reason for that is, like, let me just make something up. We talked about how we would graph this last class, and the only technique we have so far, I know a lot of us might know other techniques, but I'm assuming we only know creating this chart so far. So the reason my X is known as my input is because you're inputting certain values. You came up with those values. And then when you find what Y equals, so that would be 4, this would be 7, 10, 13, things like that. When you figure that out, that's why this would be known as your output. So you're inputting this, and then you're seeing what it equals, and it's outputting it. And I'm just going to leave it there because in other math classes, you get way more into it. I just want to expose you to that language. So what this is going to be talking about is now you're going to be given your X's and your Y's. And if you can see a pattern, can we come up with the equation? So it's almost like we're working backwards. Last class, we came up with this, but we were given the equation. Now we're going to be given the chart, and we have to come up with the equation. So sometimes it's so hit or miss. Like sometimes we can really see it easily, even for myself. And then some ones I'll look at and be like, I don't really see it. But what we can look at is, we want to just see is, pay attention to your X's. How are your X's increasing? By how many units do they increase every time?
1.
Nice. Okay. So that's good news for us. Now, what is happening here? So if I go from -6 to -3, and this is one way to check, I'm not sure if I'm doing it right yet. Then I go -3 to 0, 0 to 3, 3 to 6. Did that
Up by 3?
They went up by 3, right? So one thing I could think to do is, and sometimes there are numerous ones that we could come up with. So one equation I could come up with is Y equals, I put my X, right? And then what could be my relationship? So we know this thing went up by 3. That's looking good. And then this thing went up by 1. Because those are consistent, and I'm going to get more into this, so if this feels a little fuzzy right now, that's okay. I know it's linear. But this is where you start playing around with things. So I would say like Y equals X, and then I would say, okay, like Jonathan said, okay, we went up by 3. But let's check. If I put in -2 and I add 3, do I really get out -6? Or one that's really nice to check. If I put in 0 and I add 3, do I get out 0? No. So that one's not going to work. I'm doing this on purpose just because sometimes you want to just guess and check. I guarantee someone out there knows exactly what it is. Does anyone want to take a guess? Clarissa.
Is it Y equals 3X?
Nice.
And then I already did the next one too, but
Yeah, because now what Clarissa saw is, okay, if you take -2 and you multiply it by 3, we get out -6. If we put in -1, we multiply it by 3, we get out -3. We put in 0, multiply it by 3, we get out 0. We put in 1, we get out 3, hence output. Put into 2 times 3 is 6. Here's another thing I want to give you as an option is good old Desmos. And if you put in your equation that you come up with, all right, you can see if you're right. Let's go ahead and pull them next to each other. So what I would do is I can put in these coordinates. So I would put in -2, comma, -6. And hopefully it would be on my line. That's good. This is very time consuming, but if you want to be guaranteed you're right, or more so for more challenging ones, like, did I do this right? So I don't want you to do this for every single problem because I think it's a little bit time consuming, but I'm going to put in all these coordinates. And if they don't all lie on this line, then I know I did something wrong. Comma 3. And then 2, comma 6. And then just to give me a better foot. And then that looks really good to me. I have all of those coordinates on that line. So that equation is correct. Okay, so now let's look at this relationship. So maybe I want to just look at what could you do to 3 to get out 12? And one thing is, I'm just going to jump ahead for you. I could add 9. So let's just say I think I'm adding 9. I check the next one. Well, 4 plus 9, that won't give me 16. So that's not good. Then you could check for what could you multiply? 3 times what gives you 12?
4.
4. So you just make sure, this is the key thing, that you check every single one. What's 4 times 4? Woohoo! What's 5 times 4? Yep, 20. 6 times 4, 24. And then 7 times 4, 28. So does someone want to give me, I know Clarissa got it, maybe someone else for the equation?
Is it y equals 4x?
Awesome. And I won't spend time to do what I just did in Desmos because it will work, but I just wanted to show you that one time so that it can convince you can try it if you want. Are there any questions so far? All right. So let's try another one. So what could we add to 5 to get out 13?
Add 8.
Nice, thank you. I think that was Anthony, right?
Yep.
I always joke, like, and I probably have said this a million times. It's so funny with the Zoom world. Now I know students' voices, not faces. So then I check 6 plus 8, is that 14? It is. 7 plus 8, is that 15? It is. 8 plus 8, yep. 9 plus 8. So what would be our equation?
Y equals x plus 8.
Nice, Jonathan. Thanks, Delaney. So another way you could check it too, right, besides relying on Desmos, is just take your time and input 5, see if you get out 13, input 6, see if we get 14, input 7, and so forth. All right, let me give you all like one full minute Don't say it out loud, just so people can have their time to think and see if you can come up with the pattern for example 4. Did anyone come up with it?
Y equals X plus 5.
Nice, B. And again, you can check this because 15 plus 5 is 20, 0 plus 5, yep, 8 plus 5, 16 plus 5, 4 plus 5. Any questions so far? All right, so this one's a little different. All right, so one thing I always check for is like adding, right? So -2 plus what would give me 4? Adding or subtracting, depending. So I would add 6, right, to get out 4. But 0 plus 6, so that's out. That's not going to work. Now, what could I multiply -2 by to get out 4?
-2.
Cool. Well, if I multiply 0 by -2, I do get out 0. That's good. But 5 times -2 won't give me 25. So that's out. So I checked to adding and subtracting first, then I check multiplying. Does anyone else see what I could do to get out these numbers?
Square it.
Nice, Jonathan. Yeah, if I square -2, I get out 4. If I square 0, I get out 0. 5 squared is 25. 2 squared is 4. And 3 squared is 9. Anyone want to tell me what the equation would be though?
Y equals X squared.
Nice, Tyler. Now let me ask you, because we've learned this in the past, would you consider this thing linear?
No.
I
Good.
think so.
Yeah, remember we found out by either we graphed it and we saw that it wasn't. And the other way we know is because something was done to my x. Where this thing is considered to be linear. Because nothing is being done to that x, meaning I'm not squaring it. It's not in the denominator. I'm not taking the square root of it. So when we find this pattern, this is known as a rate of change. And the definition I'm going to give is a little different than your text because I think it's a little bit more understandable. So a rate of change is a rate that describes one quantity, so like our x's, in relation to another quantity. So that would be our y's. So us figuring out that we're squaring our inputs to get out that output, that's us figuring out this rate of change. But for us in Math 60, our main focus is just to focus on linear relationships, okay? So in the past, like we just discussed, we figured out that this thing is not linear. But another way to know if something is linear or not is that the rate of change, in order to be linear, has to be constant. So for example, this one above us, or above this thing, this x squared, that's not constant because I'm multiplying the first one by -2, the next one by 0. 5, I'm multiplying by 5. 2, I'm multiplying by 2, and 3, I'm multiplying by 3. That's not constant. What would be constant, just going back up here, more so, I'll show those ones too, but this, right? Every x, we're multiplying it by the same thing. This is constant because every single time we're adding 8. This is constant because every single time we're adding 5, and then we're going to talk about this piece in a second. This is really known as your rate of change. So if there's nothing in front of that x, it's understood to be a 1. So let me actually go back up here real quick. So this 4, that's known as your rate of change. Let me just go down here, going too slow. So here is, would you consider, I'll label this A and this B. Would you consider A to be linear just visually?
Yes.
Yeah. And would you consider B to be linear just looking at it?
Yes.
No.
And again, it's just because it doesn't look like a line. But the reason I know this is linear is visually, obviously, and we're not quite here yet. It's coming today. But it's because no matter what I do on this line, like say you're walking along it, right? Think about walking up a hill. It's the same, there's a word for it, slope, every single time. So that's what makes it constant. Where this, think about like sledding, this is more steep, then it's getting less steep, it's less steep, and then it plateaus, and then I start heading back up. That would not be constant. So now what we want to do, because now we know in order for it to be a line, the rate of change has to be constant. So there's the twofold for this lesson. One is you're given charts, tables, and you have to figure out the relationship, whether it's linear or not, just to see if you can recognize patterns. The other part of this is now we're going to be giving tables and we want to figure out if it's linear or not. So the key thing with this is you want to pay attention. Sometimes they're like much easier to stand out, right? So like I could just pay attention to my rate of changes. You want to focus on how your x's change. So how are your x's going up each time?
By 1.
By 1. Okay, so that's good news. That's consistent so far, or constant. What's happening to your y's? How much are they going up?
By 1 as well.
Yeah. So this one, so you look for that, and then you could come up with the equation because we just hopefully got more confident with doing that. What do we do to our 1 to get out 5? What would we add to it? 4, and is 2 plus 4, 6? Yep. 3 plus 4, 7? Yep. 4 plus 4, 8? Yep. 5 plus 4 is 9. So my relationship, my equation would be x plus 4. That's not really necessarily asking for this. It just wants to know if it's linear or not. So one thing you could do is you look at your relationship of how your x's are changing. You want to make sure it's constant, and you want to make sure your y's are constant. The other way you could do is you could come up with the relationship and just see, well, is this in fact a linear equation? And hopefully you're feeling better about that. So we know for a fact this is linear. But this is where, and then some of us still might even look at that table that we just did and be like, I don't really see it all that much, but I want you to get you there. But if it's not terribly clear, so for example, this one might be, but 3 to 6, that's going up 3, right? But then what about 6 to 8? How much did that go up?
2.
2, thank you, Walter. And then 8 to 12 is 4, so that's not constant. So then it's really hard to see, all right? So if this happens, and you can do it on every single problem you have out there, this is our formula to find our rate of change. We have to have this memorized, hopefully by the end of this week. I think we will, because we will just keep doing it and keep doing it and keep doing it. This is known as a slope. I can also call it rate of change, which I think is a better term for it. And what that is saying is it's saying the change, here's another way to say this, delta y over delta x. This is just a Greek letter in math that we use for change. So that's saying the change in y divided by the change in x. If that is constant, then we know it's linear. So let me just give an example. Well, let's go, we're going to go up here. Let's write these as coordinates. Bring us back to last week. So this coordinate would be 3, -2. This coordinate would be 6, -8. 8, -12. 12, -20. All right, so I'm assuming this is our first time using this formula, but we're going to keep using it for the rest of today and Wednesday, so hopefully it sticks in your brain. It does not matter how you choose your points. So the first 2 points I'm going to look at are 3, -2, and then 6, -8. So I'm just choosing these two in my first one. Is everyone okay with these are your y's? That the yellow are your y's and the greens are your x's? Because that's the most common mistake. So what this formula says is you choose your second y and you subtract it from that first y. So my second y is -8 minus -2. Divided by. Here is the key thing. It doesn't matter if someone out there said, no, Stephanie, I want to say -2 minus -8. That's okay. Just as long as whatever you pick first. So I picked -8. That's what I chose to do. That means down here, I have to pick from the same coordinate. So it has to be that 6. So what I'm saying there, I'm a little nervous that it wasn't clear, is that these have to be from the same coordinate and these have to be from the same coordinate. Otherwise, you're making up a new formula. The other key thing is the formula says y divided by x. So now if I clean that up, -8 minus a -2 becomes -8 plus 2, so I get -6 over 3. What's -6 divided by 3?
-2.
Good. Okay. So far I got my slope between these 2 points is -2. That's my rate of change. Now, what I want to check for, I don't just stop there. I got to check these 2 as well. So I'm going to run out of space, but I'm going to go over here. Here are my 2 points, 6, -8, and 8, -12. My slope, I'm going to refer to looking at the formula because I'm assuming it's brand new for us. My y2 is -12 minus, what should I minus it? What should go next?
-8.
Nice. Here's the key thing, divided by what has to come first. Is it the 8 or the 6?
8.
Nice. 8 minus 6. Okay, so I get -12 plus 8, so that's -4. And then 8 minus 6 is 2. So do I get -2 again? Check my work. Looks like I do, right? So let me just move this a little bit over. I'll rewrite that. So we found this slope also to be -2. Now we have to do the next 2. So M is, let's actually write those coordinates down. It's 8, -12, and 12, -20. Order doesn't matter. It really doesn't, as long as you're consistent with your formula. So let me just show what I mean by that. Say you're like, no, Stephanie, I'm going to choose -12 first. You get to do that if you want. What should I minus it? What goes next if I choose this one? Should be minus.
-20.
Good. Divided by, this is the key thing. If you want to change the order on me, that's fine. But because you chose -12 first, you have to choose 8 first in the denominator. -12, that becomes a plus 20. So we get, whoops. We get 8 over, what's 8 minus 12?
-4.
Awesome. And what's 8 divided by -4? -2. So because we got our slope to be the same, right? We got -2, -2, -2. That tells me this thing is linear. So sometimes, if you can just look at it, please, because you can see how much work that was, but sometimes it's not terribly clear. So it looks like, so what that's telling me is I should be multiplying my x's by -2. This is more than the question is asking, but what if you multiplied 3 by -2? What would you get?
-6.
Awesome. What could you add to -6 to get out -2?
Add 4.
Yeah. So let's see if that works. I'm not asking you for the equation, but just to get us thinking more. If I do -6 times -2, or sorry, forgive me, 6 times -2, I get -12. I add 4, I get out -8. 8 times -2 is -16. I add 4, I get -12. 12 times -2 is -24. Add 4, I get -20. But all we're concerned with these, so your relationships won't be that challenging when you're trying to come up with your equations. But I just wanted to relate it to what we were just doing. So let's say you did all this work and you got -2 for this slope, you got -2 for this slope, but you got 1 for this slope. Would you consider that linear?
No.
No, they all have to be exactly the same. I'm going to wait until we get to the next set of notes to talk about this piece in the definition, because I think it'll make more sense when we're looking at a graph. Okay. So what we're going to do now is we're going to determine if A is linear together. And then you're going to go into breakout rooms and figure out if B, C, and D are linear. So some of them, if you can look at it, please do. And if you can't, if like just looking at it, it's not working, sadly, you got to find that slope a million times. So this one, A, is going up by 1 each time. So that's looking good. What's happening to my Y's?
Decreasing by 2.
Good. The fact that that's consistent, another word for that is constant. It's constant in my X's and it's constant in my Y's. Then I know this thing is linear. Okay, let me go ahead and let's look at B together too, just so I don't throw you to the wolves quite yet. Now, the first thing you're going to do is see how are your X's. Well, no, this one's not that. No, it is. No. Okay. How, sorry, I thought it was going in 9 to 11. How much is that increasing?
16. Or
Sorry.
it's increasing 2 on the X and then 16 on the Y.
Yeah, so 9 to 11 is increasing by 2. 11 to 14 increasing by 2. 14 to 16, 2. 16 to 18, 2. It's looking good, but make sure you check your Y's, and Clarissa already saw it.
11 to 14 is 3. Sorry.
Thank you for catching. I thought thank you so much. So this is 3. So that's where, something went wrong. Thank you so much for catching that before I went on. Now, if we look over here, this went to 16, right? If we do 166 plus 16, we don't get 190 either. Now, this is the thing you have to be careful with. That doesn't mean it rules it out from being linear. It would be much easier if, just this 3 was the mishap. But what we want to do is go ahead and find that slope. So I'm going to go ahead and erase this. So my slope for these two, it's going to be 166 minus 150 over 11 minus 9. 16 divided by, what was that, 2 again? So I get 8. Let's find this slope, and we can probably see what's happening. I'm going to say, and you guys let me know if I'm losing you at all, because I'm not writing these as coordinates. 190, because that's my Y2, minus 166 over 14 minus 11. Apparently I need help with my arithmetic today, so I'm gonna relay my calculator. I get 24. What's 14 minus 11? Which Anthony helped me figure out, 3. What's 24 divided by 3?
8.
8. Okay, so it's looking good so far. So I don't want you to just rule it out because there's just like a jump in your graph or your chart. So, but let's don't assume just because you get 2 to be the same that it's all going to work out. This is going to be 206 minus 190 over 16 minus 14. So again, we get 16 divided by 2.
Yeah.
It's looking good so far, but this is the key thing. And you know, I hate to say it because I know students always say it. I'm like, I promise we're not out there to trick you. But a lot of times in our book, this last one will be the one that throws us off. I'm not saying it will happen this one, but just make sure you check all. 222 minus 206 over 18 minus 16. And I believe we get 8, don't we? Oops, sorry, I hit something. So we get 8. So that makes this thing linear. So what I'm going to do now, I'm going to put you in your breakout rooms and you have the next 2 to just figure out if they're linear or not. Okay. So let me just for recording purposes, because I forgot to record. See, we got not linear and then D is linear. Another way we could say this also, just so you realize, we could also say non-linear. Both are the same. All right, so now they give this beautiful chart. It's our table. Gives us the population estimates for Portland, Oregon from 1990 through 2014. So there's a lot of numbers there. You know, this is not going to be linear because that's not how our population grows. Because there's a lot of inconsistencies, but they do want us to find the rate of change between 1991 and 96. So what we're going to do is we're going to find 1991, that's our year, and then that's our population, and then 1996, and there's our population. And just so you know, usually, if not all the time, our time is our X, and then whatever we're dealing with is our Y. So let's write those 2 things as coordinates. I could write that as 1991, comma, what is that? 491,000. Maybe I won't put a comma because I think it might be confusing. And 64. So that's one coordinate. And then the other coordinate is 1996, 501,646. So I'm going to use this slope formula. I'm going to write it down over here so we know it. Y2 minus Y1 over X2 minus X1. So if we want to find this slope, again, it's okay if you don't choose to write Y2. So what's our Y2? You want it to be 501, blah, 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 or 491?
501.
Yeah, okay, so 501, 646, then I subtract the other Y. So think about this too, like something we learned when we first met each other is combining like terms. Only Y's can be combined and only X's can be combined because they're like terms.
And when you're putting it together, is the X always on the left and the Y is always on the right? Like in order?
Yes, always, always.
Okay.
Good call. Yeah, so I like to think about like the alphabet. X comes before Y. Now, because our little hearts chose this first, that means has to come first in my denominator. And this, my goodness, definitely needs, for me, a calculator at this moment. I'll turn on my lights more. So I'm going to do 501,646 minus 491,064. I get 10,582. And then that would be 5 years. And then if I divide this by 5, so I wonder, they might want you to leave it like this. I should double check with WebWork. Or we can leave it, we can actually do the division. And actually, it's not approximately, it's just exactly. So that's telling us between those 5 years, if this thing was linear, it increased, our population increased 2,116 like people per year. We won't say 0.4 we should say, but if we're thinking about it in context, it's hard to think about a 0.4 of a person. Winter, I saw you had a question. What was it?
Oh, I was just asking if it matters, like which, like on the table there, which two like things we choose to use, like which numbers we choose to use.
It does, because they specifically tell you which ones.
Okay, and would that happen all the time or?
Yeah.
Okay.
Okay, actually, let's be, with something like this, yes, because this isn't perfectly linear. So if they gave us a table and they say, let's just claim that this is linear, I'll say, okay, this is our population, it grows linearly, then it wouldn't matter which two you choose. Because if it is linear, that means your slope is the same no matter what, right?
Mm-hmm.
But they're specifying because this thing isn't really linear.
Okay, so most of the time I should just like assume that it's gonna tell me.
Yes, right. If it
Okay.
doesn't tell you it's linear, then we'll specify the two to choose, or they might even make you do all of them, which they wouldn't with this because this is way too much data.
Okay, sounds good.
Yeah. So I want you all to do the same thing, but now you're going to do it with 2008 and 2014. And then I want you to attempt C. It's talk about C in your breakout rooms too. So I'm going to put you in your breakout rooms again. To get 10,486.33. It was repeating. You could just write point. I don't know what WebWork wants. I double checked and it didn't say rounds. So it looks like point, it rounds to the hundredths, so the second decimal place. So here's something that I should mention, and I didn't. Units is important. I wasn't mentioning it before because we were just looking at data. So all of this stuff is wonderful data. I don't know what I'm talking about in these previous examples, right? I don't know if I'm talking about people. I don't know how many sweaters I can make, how many pizzas I'm going to eat, whatever it is. This, I clearly have units here. So this is really important. What is in your numerator? Is it people or years?
Years.
Years. No, it's not. People.
Oh, people. Sorry.
No, I didn't. I just go. So it's people per year. So we should have units when we can. So this other one, it's people per year. And WebWork actually lets you know to use that unit, like says to use the units. So when you do have units, we should use them. Yeah, Delaney.
So for B, you have it 2008 minus 2014.
Uh-huh.
Why did you do it in that order?
Oh, good call. So I'm so glad I did it. I didn't do it on purpose because it doesn't matter.
Oh, okay,
So
okay.
a lot of us get attached to Y2 and X2, and that's great. The thing that matters the most is if I choose this one to go first, then just make sure that X accompanying it goes
Got
first.
it. Okay,
Awesome question. Yeah,
thank you.
yeah. So a lot of you might not have had to deal with negatives if you did it the other way. So again, don't forget to do these units.
So is Weber gonna be really picky? Like
With
with all this the unit part?
you only have like one question and it's like this, right? So like I couldn't use units at all up here because I didn't have any. So it won't be that much, but if you're ever in a context of a problem, right? Because we're doing population, which is people in my numerator, and we're dividing by years. Whenever we're given units, we should say it in our answer.
Okay.
Let me just see. I'm gonna just double check again.
Oh, really quick. I just
Yeah, it
want to
says you can
remind
type
that
the unit as people divided by year. So it actually
Oh.
says specifically what you can type the unit as.
okay. Something that like I have like a kind of buddy that I'll ask for some help. Adam.
Mhm.
Adam had made a really good point, just in case like anyone has any issues, is if you click the show more, it'll show you a problem exactly like what you're looking at. And then if you look at solution, it'll tell you how to do it.
Yes.
So just a reminder, if like anyone gets stuck out there, it's like it's a really good thing.
Yeah, and last term I didn't have that marked, and it wasn't because I didn't want to, I just didn't have it marked. So I made sure it was marked this year. So yeah, it's a really nice, helpful way if you want to see an example of the exact problem you're working on. Good call, Alex. So now the last one says, list all the years where there is a negative rate of change. So what that means is if I look at 1990 to 1991, would you say your population went up or down?
Up.
Up, right? Okay, cool. Keep looking. Looks like it's still going up. It's still going up. That went up, yep. Did that go up? Yep. That went up, up. What about from here to here? Let me get rid of that. Did that go up? From 97 to 98, did our population go up or down?
Up.
It went down, right? Because we were at 503 and then we go to 502.
Oh, I see.
So that year in 1997 is where our population started to go down. Another way of saying that is that we had a negative rate of change. So if our population is going up, our rate of change should be positive, and if our population is going down, our rate of change should be negative. Now that might not be the only year, so this is where you'll start to appreciate what.
That was the year of tragedy.
That was a tragedy?
Maybe they lost some people in like a mass shooting.
In 97?
Maybe, I don't know. Just
Oh, okay, yeah, you're right, maybe, yeah.
Wasn't that the .com bubble bust?
97, yeah, I guess so, like around 97 and 99.
Ooh, they had some really bad music too.
They had really bad music too. So Lexi just asked a really good question. And Lexi, I had to really play around with web work to make sure of how they want it, because I didn't realize if you wrote that. So Lexi put in the chat, like if she wrote 97 to 98, that would be okay for me. But again, this is a program and it only accepts it certain ways. It only wants you to say the year that it started going down. So I'd say 1997. Then I'm going to keep looking. Okay, so 98 to 99 goes up. 99 to 2000, up, up, up. My eyes are getting tired. Here, does that go up? That went down, right? Can we buy that? That my population went down?
Yeah.
Wait, did you not do 98?
You just list the year that it starts to go down.
Okay.
So I'm just gonna list there 2003. I'm gonna keep looking because I don't know if it's only 2, so don't assume anything. Here it goes up, 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 up. I'm like not trusting my eyes at all. Okay, so it looks like those are the only 2 years. Someone wrote 99. Good catch. 50, no, not good catch. Sorry. I don't mean to say that. 503 to 529, that goes up. My eyes were looking at it as 502. Maybe yours were too. Any questions with that? So Lexi says 99 to 2000. No, because 503 increases to 529, so it went up. You didn't have to find it. I know,